Hi, welcome back to our Honors Geometry playlist. In this video, we're going to talk about section 5.5, the triangle inequality. So the sum of the length of any two sides of a triangle must be longer than the length of the third side. So what does that mean? If I have any two lengths of a triangle, so let's say this is 11 and this is 9. Those two added up must be greater than the third side. Even if it's just by a little bit, it has to be greater than the third side. So even 19.5 or 19.9, excuse me, could work as long as it's greater than, so as long as this sum is greater than the third side. Now 19.9 would create a very large angle up top, but it's still possible. And why is that necessary for those two sides to be longer? Well, if they were shorter, I could lay them end to end and they wouldn't make a triangle with the third side if they were shorter than that third side. So I could lay these end to end and they wouldn't make a triangle. Or if I tried to connect these, I wouldn't have enough length to make a triangle. There's this big gap in the middle here because those sides are too short. So what I have to do to check if it's possible to form a triangle with a given set of numbers, I need to make sure that any two sides would add up to be greater than the third side. So typically I check with the two smaller ones. 2 and 3 here, if I add them up, makes 5. And since that is greater than 4, I know that that must be a triangle. And of course, I could do the same thing with 3 and 4 would make 7, which is much greater than 2. Or 2 and 4 make 6, which is greater than 3. I like to usually start off with the smaller, or the smallest two, rather. So this one would make a triangle because any two sides added up would be greater than the third side. Here again in example B, I would try the smallest two. Those add up to 12, which is greater than 9. So that should work. I could also check 7 and 9 is bigger than 5, or 9 and 5 is bigger than 7. On C, I have 13 and 13, which gets me 26, but that's equal to 26. So again, if we think back to our example up above, if they were just equal, I'll do my best to get it very close. If they were just equal to the third side, if the sum is equal to the third side, all that would do is they would just lay right on top of that third side, but they wouldn't be able to make any angle. So this is no. The sum must be greater than the third side, and it is not there. So I'm going to actually scroll down to a slightly tougher problem. We're going to talk about another example here. So I have 3 and 5. If these were my two smaller sides, what are some numbers that the third side could be? Remember, these two must add up to be greater than the third side. What could be 7? Or it could be 6, or 5, or 4, or 3. Any of those would work, because the sum of the two sides, the sum of any two sides, must be greater than the third side. But what happens if I put in variables? Well, you get the same thing. So if I were asking you to solve for the range of values that x could be, Well, you just have to remember that the sum of any two sides should be greater than the third side. Or here I could have 6x, that should be a minus 1. That's not what I wanted at all. Okay, so 4x minus 1, 6x plus 6 greater than x plus 13. 5x is greater than 7. So x should be, if I wanted a range, x should be greater than 7/5. And instead of adding up these two and setting them greater than the third side, well, I could do that these two added up should be greater than the third side. So I could say 2x plus 7 plus x plus 13 is greater than 4x minus 1. So 3x plus 20 greater than 4x minus 1. So x should be less than 21. And that's just a quick video on our triangle inequality, finding the different side lengths and the ranges for x. Check out our other videos on how to find a specific range given two numbers, and our hinge theorem video coming up shortly.